In this video, we're going to be solving Leetcode question 199, which is binary tree right side view. Let's get started. So in this problem, we're given a binary tree, and we need to imagine we're observing the binary tree from the right-hand side. So this is us, the observer, right here. And our goal is to return all the nodes that we can see from our point of view in order from top to bottom. So in this example binary tree, we can see the nodes 1, 3, and 4, but we can't see the node 2 because it's obstructed by the node 3, and we can't see the node 5 because it's obstructed by the node 4. And then we return the 3 nodes we can see in order from top to bottom, so we return a list of 1, 3, and 4. So this question involves searching a binary tree. And because it's a searching type question, it would make sense to use one of the main searching algorithms. And there are two. We could either use breadth first search or depth first search. And now it turns out that both searching algorithms are going to be roughly the same in terms of efficiency, but we're going to start with breadth first search because I feel like the solution is a little bit more intuitive. But we're going to go to depth first search afterward. We are looking for the nodes that will be visible to someone who is viewing the tree from the right-hand side. What that means is for every layer of the binary tree, we want to find the rightmost node because that's the one that will actually be visible to someone looking from that angle. Okay, so now we know that we want to find the rightmost node for each layer in the binary tree. So now we need to find a way to do that using breadth first search. Let's imagine that we already have the current level of the binary search tree. So we have a list containing all the nodes in one particular level, in this case, the second level of the binary search tree, and all the nodes are placed in order from left to right. How can we use this list to generate the list of the next layer of nodes in the binary search tree, also in order from left to right? Well, what we could do is we can go through each node in the current list and then print out the left value, the left child, if it exists, and the right child, if it exists, and then append those to the next level list. So for instance here, the first node in our current level is 2. So we check for 2's left neighbor, left child, which it doesn't have, so we don't add anything. But it does have a right child, so we add the value 5 to the next level. That's easy. And then we go to the next node in the current level, which is 3. 3 also doesn't have a left child, but it does have a right child, which is 4. So we'll append 4 to the list. And now we have the next level, level 3, also in order from left to right. And now it's super easy to find the rightmost node because we just returned the last element in that list. And we already know the order for the first layer of the binary search tree because there's only one node. In this case, it would just be a list containing the value 1. Since we know the order of the first layer, we could use the technique I described earlier to get the second layer order, and then use the second layer to get the third layer. And we can keep doing this until we get to the end of the binary search tree. We know we're at the end when one of the lists, which describes all the nodes in a given layer, has a length of 0. That means there's no more nodes in that layer, and there's not going to be any more nodes to search for in the entire list. And in this algorithm, we're going to be visiting every single node exactly once. So that means the time complexity is going to be O of n. And the space complexity is also O of n because we store each node exactly once in one of the arrays. So now that we have the algorithm down, we can code it up. If you're finding these videos helpful, I think you'll love what we got going on in our private community. We dive even deeper with exclusive content that won't be shared on the main YouTube channel. I also offer individualized coding interview study plans that are tailored just for you. You can also join small group sessions, participate in mock interviews, and get your questions answered in live weekly Q&As. It's a great way to take your coding interview prep to the next level. If you're interested, check the link in the description below. I'll see you inside. All right, so here is the Python code for solving Leetcode question 199, which is binary tree right side view. First, we're gonna check that the root value exists, because if it doesn't, we can just return an empty list. There are no nodes in the binary tree. Assuming that the root value exists, we're going to set the variable current node level equal to a list containing the value root, because we want to get the current list of the current layer of the binary tree in order from left to right. Since there's only one value, the only value in the list is going to be root itself. And then we're going to initialize next node level to an empty list. we're also going to have another list, visible node vals, which is going to give us, going to collect all the visible nodes, so the rightmost node for each layer. We're going to set up a while loop, and we're going to append the last value in the current node level, which in this case is going to be root, but in general is going to be the rightmost node on that layer. And then using the current node level list, we're going to generate the next node level list. The way we're going to do that is to go through each node. We're going to take the left child, if it exists, and append it to the next node level array. And then we're going to look to see if the right child exists and do the same thing. And after we're done populating the next node level, we're going to check if it has a length of 0. If it has a length of 0, then that means there's no more nodes that are on that layer, and that means we've looked at every single node in the binary tree. But assuming that there is at least one node in the next node level, we're going to set next node level to current node level. We're basically going down one step on the tree, and we're going to reinitialize next node level to an empty list. And we're going to keep doing this until one of the next node levels gets 0 nodes. And then after we're done, we're just going to return visible node vals, which keeps track of all the rightmost nodes for every single layer.